Hey everyone. So at this point you should have guided notes for 4.1 in front of you. So we're going to start with the warm-up, and I want you to try this on your own. So for 1 and 2, it says find the slope. 1 and 2, I want you to find the slope. And then for these, find the missing value in the point. So this would be what we tried yesterday, where we would say, for instance, that the slope is -1/4, and we would set that equal to y2 minus y1 over x2 minus x1. So go ahead and pause the video and work on these and then check them with your neighbor friend. Okay, now that you've come back, let's go ahead and check your work. Okay, so here is the work. So for the red number 1 here, we just have the slope, -7/11. You notice that I did y2 minus y1, x2 minus x1, and then I did the same thing for number 2. We have an undefined slope, so we know this is a vertical line, and it's 3/0. We can't divide by 0, so that's undefined slope. Then over here, the light blue one, again, I just did -1/4. And if you'll notice for the ones down here, I actually did y1 minus y2 and x1 minus x2. Again, it doesn't matter which one you do first as long as you keep it consistent. I just thought it was going to be easier to have the variables not have a negative in front of them. So this is the way I went. The other way works perfectly fine too. So I ended up multiplying by 4 to get rid of my fractions, and I got w equals 5 and t equals 5. So everything equaled 5 on this side. For the dark blue number 2, again, I figured out what this was. I butterflied, so I cross multiplied to get rid of my fractions, and then I get t equals 5. Okay, so you weren't familiar with standard form, but you did know slope-intercept form. So here it is, that lovely thing you've been waiting for, slope-intercept form. So the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. So again, in this particular case, 2 would be my slope, right? And 6 would be my y-intercept. And when I say 6 is my y-intercept, that means that when x is 0, y is 6. And if I wanted to be a little bit more specific, b is the y coordinate, right, of the y-intercept. If I wanted to be a little bit more specific, because that b is that 6, the y coordinate of the y-intercept, whereas the y-intercept is actually 0,6, just to get technical. But basically, again, that y-intercept is just where it would be crossing that line. Okay, so now we're going to write the equation in slope-intercept form. So instead of standard form, we're going to write it in slope-intercept form. You'll note that most of these, not all of them, are in standard form. So we're just going to switch it to slope-intercept form, then identify the slope and the y-intercept. So the key to this really is what we want to do is we want to isolate our y. Okay, and you want to think, I want it to look like y equals, so y by itself, mx plus b. All right, so in problem A here, what I'm going to do first is I'm going to get rid of 2x on both sides. So I am left with 3y equals a -2x plus 6. And I want y by itself, so I'm definitely going to have to divide by 3 on all sides. So that's all of this divided by 3. So that goes away, and I have y equals, and then I can split this 3 up into both things, right? So -2x over 3, that's not really divisible, but 6 divided by 3, sure, that's just 2. Okay, so in this particular case, my slope is whatever is in front of the x. So my slope is -2/3, and my y-intercept is going to be the point 0, comma 2. And again, the 2 comes from here, and the 0 comes from the fact that it's a y-intercept, so x is always 0. Okay, here's another to try. So let's look at B. So again, I want to get y by itself, so I'm going to get rid of negative 4x on both sides. So goodbye. And that's negative 2y equals negative 4x plus 4, because that's what I'm left with. I can actually reduce this because they're all divisible by 2. So I'm going to just reduce that a bit and recognize, oh, okay, so that's just if I divide everything by 2, that's just negative y equals negative 2x plus 2. So I've reduced the form a little bit, but I need to get rid of the negative. So I'm going to divide everything by negative 1. Now, had I thought this through, I could have just divided everything by negative 2 to begin with, but I didn't do that. I just made it a little bit harder on myself. Okay, so there's my equation. So for this particular equation, again, my slope is going to be 2, and my y-intercept is going to be 0, comma, and then you see that negative in front, so I need to say negative 2. Okay, I want you to try try C and D on your own, and I want you to get the equation, find the slope and the intercept, and then I want you to check it with a neighbor friend. Go ahead, we can pause the video. I'll wait. Okay, now that you're back, let's check our work. Okay, so looking at C and D. And so looking at C, I added x to both sides so that I could get the y by itself. I ended up with a negative y, which wasn't so much fun. So then I divided everything by negative 1, and I ended up with y equals negative x plus 7. There's that invisible 1 in front of the x, so my slope is negative 1, and my intercept would be 0, comma 7, again, because there's a positive intercept there. So then for D, I was like, well, I'm going to keep the 3y on that side. So I'm just going to subtract 9 from both sides. And I get 3x minus 9 equals 3y. So that's pretty much the same as this equation up here. And so then I divided everything by 3. And I got x minus 3 equals y. So again, there's an invisible 1 in front of the x. So my slope is 1 and my y-intercept is 0, comma negative 3. I wanted to do E together because E is just a little bit weird. I need it to look as much like that formula as I can. So I'm going to isolate y by itself. So I'm going to divide both sides by 7. And I end up with y equals 3. Okay, so technically that's the same form as above. It's really just saying y equals 0x plus 3, right? So in that particular case, I forgot you guys like it better when I do this, 0x plus 3. So in that case, since there's no x, it's really just 0x. So my slope in this particular case is 0. And my y-intercept is going to be 0, comma 3. So again, if I just see y equals 3, you have to remember, well, it needs to look like this. So there must be this 0x in the front. Here's the fun part, graphing. Okay, so when I have a formula like this, I like to start with my y-intercept. So I see here it's in perfect form. I don't have to change the form. So I know that my y-intercept, right, is going to be 0, 1. So that's actually the first point I'm going to plot. So I'm going to find 0 on my x and 1 on my y, and I'm going to plot it right there. So this is the key one. Plot this first. Okay, now I'm going to go to the fun part, the slope. So we know the slope is 2. And we know that slope means rise over run. So I can reword this to 2 over 1, which means it's going to go up 2, and because this is positive, it's going to go over 1. And then I'm just going to essentially go up 2 and over 1 to make the additional points. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay, now I can go the other way too to go backwards. I'm going to go over 1, but in the opposite direction, and down 2, over 1, down 2, over 1, down 2. So you're probably thinking, what? How did you do that, Ms. Shope? What's that about? Well, let's retrace our steps here. If I start here and go up 2 over 1, up 2 over 1, up 2 over 1, I get back to the intercept. So I just essentially went backwards. Instead of, to go up, I did that. To go in the opposite direction, I did the opposite on both sides. So I just did the best I could on a computer, and I took a straight edge and I connected all the dots. So if you haven't already, will you make sure that someone in the back passes out a straight edge to everyone so that everyone has a ruler that they can do on their own map? If you haven't already, I'll go ahead and wait. You could pause the video. Got it? Awesome. So now connect the dots and don't forget an arrow going both directions. Let's try another one. So again, I'm going to start with my y-intercept, and my y-intercept in this particular case is right here. So my y-intercept in this case is going to be 0, 4. And so I'm going to go 0 on my x and 4. So that's 1, 2, 3, 4. I'm right there. Okay, so I'm going to go and look at my slope here. And my slope, because there's an invisible 1 there, is -1. So remember, it's rise over run equals -1 over 1. So I'm going to rise -1, right? Which means I'm going down. So I'm going down 1 over 1. And then this will be my line. Okay, so down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then I can do the opposite over here. Okay, so as I go from left to right, it's down, over, down, over, down, over, down, over. Okay, so again, let's pause, or I'm going to pause and graph it real quick. You go ahead and connect the dots as well. Oh, look at that pretty line. Okay, so now we have a line that connects all the dots, and I have 2 arrows going in either direction. Okay, so now what happens when it's not in the perfect form? Well, I gotta put it in the perfect form. So I'm going to subtract 5x from both sides. Now I'm getting 4y equals -5x plus 8. Still no good because I'm going to have to divide by 4. That's going to be y equals -5/4 x plus 8 over 4. 8 divided by 4 is 2, so I'm just going to say 2. All right, so now that I know that, okay, my intercept is just 0, 2, and then my slope is -5 over 4, which means this is the rise and this is the run. So again, I just like to do a rough sketch. That means I'm going down 5 and over 4. Let's start with the y-intercept. This is always where I like to start. So 0, 2 is my point. And now I'm going to go down 5. 1, 2, 3, 4, 5 over 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, I can go in the opposite direction. I know it would be up here somewhere because I can see the pattern. So I'm going to have to go down 5 over 4. So I'm going to go backwards over 4. Whoops. 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. Okay, so again, it's hard to do the other side of the graph. I just think, oh, what would it kind of look like? I'm going to go over. I'm basically going to switch directions on both sides if I'm going right to left because I'm reading it backwards. So I got to switch it backwards. Okay, so go ahead and connect the dots. Okay, and then there's my beautiful graph. Trying to go through all the points as best as I can on a computer. I'm sure yours is so much better with your lovely straight edge. This one is one that I want you to try on your own. Notice that it's not in my slope-intercept form, so I've got to change it. So first, change your equation, then find the y-intercept, then the slope, graph your y-intercept, and do your rise over run. Okay, I'm going to pause the video to give you some time to work. Hopefully you've checked with your neighbor friend, so let's go ahead and come back and take a look at this. Okay, so I took away 3x from both sides, and I get 2y equals negative 3x plus 6. I divided both sides by 2 to get y by itself, and then I reduced. So I ended up with a y-intercept of 0, 3, and I ended up with a slope of negative 3 over 2, where this is my rise, and this is my run, so it's going to go down 3 over 2. Again, I draw this almost every single time so I don't get confused. So there's my point 3, and I'm going to go down 3 and over 2. So my next point, down 3 over 2, over 2, down 3 over 2, down 3 over 2. Then over here, I'm going to do the exact opposite because I'm going backwards. I'm not reading left to right anymore. Now I'm going right to left. So I'm going to go over 2 and up 3. 1, 2, 3. Over 2 and up 3. 1, 2, 3. Connect the dots, and there you have our line. What about this shenanigans? So what this is saying is it's saying x is always equal to negative 4. So it means no matter what the y is, the x is negative 4. So if I ever see x equals a number, it's going to be a vertical line through that number. And then it's always going to be an undefined slope. So in this case, it says x is always equal to negative 4. So 1, 2, 3, 4. Here's x is negative 4 when y is 0. X is negative 4 when y is 3. X is negative 4 when y is 1. Every single time, x is equal to negative 4. So we're just going to make our line. That line's not great, but there we go. That line's a lot better. And I just see, boom, every single time x is negative 4. So that's what we do when we see something like that. What about when we see y equals 6? Well, this means that y is always 6, no matter what the x is. So when I see y equals a number, I know that this is going to be a horizontal line. So this is a horizontal line through the number. And this always has a 0 slope. Okay, so in this case, it's 6, so y is always 6 no matter what. I'm going to go up 6. 1, 2, 3, 4, 5, 6. Make a little dot. And then just know that my line is always going to be right here Boom. With arrows on either side always. Y equals 6 and the slope is 0. So I think at this point you're probably running out of time with the quiz. So this is just a thinking problem. It's a real world algebra problem, and we'll talk more about how to do these tomorrow. But if you want to challenge yourself and you've got some extra free time, you could try this problem and this problem. And on both of these problems, you're just trying to turn the words into a linear equation. So in slope-intercept form is an easy way to think about these. So, but again, these are just for a challenge if you have some extra time. Meanwhile, this is your homework assignment tonight. I'll leave it up for a bit so you can write it down. And then this is due tomorrow. It must be on graph paper. If you don't have graph paper, please walk over to the place where I keep graph paper and grab yourself some. Okay, if you haven't already, you can pause the video to write this down, and I will see you hopefully tomorrow. Bye.